I welcome you all in this presentation related with the subject materials processing, fundamentals and practical, and we are talking about the metal forming processes, and in this particular presentation I will be talking about the wire drawing process. So, this is the process which is primarily used for making the wires, but if they are of the large diameter, then we can call it like this is also used for making the bars and rods of smaller diameter, wherein the stock material is of the larger diameter. So, basically in this process the cross sectional area usually which is diameter of the stock material is reduced to produce the bars, rods and wires. Okay. In approach wise, this process is similar to extrusion process, where we have seen large reduction in cross section is possible through the extrusion, but there we can obtain the variety of cross section as per need. But in wire drawing, primarily we obtain the diameter of circular cross section, means the wires, rods and the bars of circular cross section. Okay. Otherwise, approach wise it is similar. There is one more difference, that the way by which the reduction in cross section which is achieved. So, the extrusion becomes different from the wire drawing in terms of the stresses which are applied for realizing the desired reduction in cross section. About that we will be talking in detail. So, as far as content is concerned of this presentation, we will be talking about the approach of the process and the overview in general, like what the process approach is, how the material is affected and how it can be done effectively to fasten the process for enhanced productivity and producing the wires free from the defects, like that. And the second one is the material and the wire drawing process. So, how the material properties will be affecting the wire drawing, or how the wire drawing will be affecting the properties, mechanical properties of the wire which are being produced. Then we will also be talking about the mechanics of wire drawing, where we will try to see how the stress, true strain related with the wire drawing and the force required for wire drawing and the power required for wire drawing can be obtained. And at the end we will try to see the common defects which are observed in the products which are made using the wire drawing process. So, as far as the overview of the process is concerned, here the wire drawing process, let us see, this is the large diameter, the bar. Okay. Then it is forced to pass through this die. Die is of the smaller diameter. When it is forced to pass through the die, the diameter of the bar is reduced. Okay. So, this kind of the reduction in diameter basically is obtained by applying the pull force. This is the one major thing. We are realizing the reduction in cross section, but by applying the pull force. While in case of the extrusion, what we have seen, that we have to apply push force or compressive force is applied, but here we apply the tensile force. Okay. Here the design of the die plays a very crucial role in ensuring that the flow of material takes place when the tensile force is applied, so that the diameter is reduced and without necking or fracturing possibility. Okay. The wire drawing is basically a cold working process. Okay. So, when we perform the cold working in a metal, it experiences the work hardening. Okay. So, since the process is cold working, so it is usually done at the room temperature or below the recrystallization temperature without external heating usually. Okay. So, it is done below the recrystallization temperature. This is the process approach as far as the temperature conditions are concerned. So, the wire drawing is basically a cold working process, and since the plastic deformation occurs at a temperature less than the recrystallization temperature or usually room temperature, material experiences the work hardening. Whenever there is a work hardening, huge number of dislocations will be produced, and that will be increasing the resistance for the movement of other dislocations, increasing the stress required to cause the plastic deformation. So, since the deformation is happening under the room temperature conditions or below the recrystallization temperature, it experiences significant work hardening, and therefore there will be increase in strength of the material which is obtained in form of wires, okay, an increase in hardness. But this happens at the cost of the ductility. Okay, ductility is reduced, strength, yield strength and hardness of the material is enhanced due to the work hardening. So, this is the second thing that happens. The process is involves a significant reduction in diameter. So, the die which is used helps in reducing the cross section of the stock material which is being used. So, metal is pulled through the series, either one die or series of the dies, until we get the desired reduction in diameter. So, each the die will be of a smaller diameter, and that will help in continuously successively in reducing the diameter of the material which is being pulled through the different dies or series of the dies, and therefore it is usually multi-pass. So, multi-passes through the different dies needed to achieve the desired final wire diameter. If we see here that this is say die, one die, and the material is being forced to or being pulled through the die. So, there will be huge interaction contact between the die surface and material which is being pulled through the die. So, because of this firm metal to metal contact, significant friction is observed at the die metal interface, and that leads to the increased requirement of the force which is required to facilitate the wire drawing, and therefore to reduce the frictional effect, what we do, we use suitable lubricants so that the friction between the wire and die can be reduced, and wire drawing can be made more smoother process without much damaging the wire or die. Because when the wire is or rubbing continuously the surface of die, it will be experiencing the adhesive wear. Okay. So, there will be continuous loss of the material from the die surface, and that in turn will be increasing the diameter, and so changing the diameter of the wire that will be produced. Therefore, it is important that for the longer life of the die as well as for the reduced force required for wire drawing purpose, if the lubricant is used, suitable lubricant is used, then that will help in reducing the friction between the metal and the die, and that in turn will help in reducing the wire drawing force power required for wire drawing, as well as that will also help in increasing the life of die. Okay. So, as far as the approach of the wire drawing is concerned, the wire drawing process is used to produce the wires. These can be of the any metal like the steel, aluminum, copper, which can subsequently be used for variety of the engineering applications. So, these are produced using the stock material which is relatively larger diameter in form of bars and rods, and this is passed through the suitable die to produce the wires. So, here what we do first, we take the large diameter stock material in form of bar or the rods, then it is tapered. Okay. Then it is tapered so that it can be entered through the die, okay, and then tapered end is then pulled. Okay. So, initially the bar is tapered and then it is passed through the die, then tapered end is pulled. Okay. So, tensile force is applied, and when the tensile force is applied, die design is such that it ensures the smoother plastic deformation of the material rather than necking due to the application of the tensile force. So, this plastic deformation facilitates the reduction in diameter and increase in length, okay, due to this when the material passes through the die due to the pull force. So, the design of the die therefore is very crucial. If we see carefully, when we apply the pull force, the material will be experiencing the compressive stresses due to the constriction that will be offered by the die surface. So, we apply the tensile force, but the material experiences the compressive force, and which in turn will be leading to the reduction in cross section. Okay. Here the design of the die is crucial, otherwise what will happen due to the application of the tensile force, somewhere necking will start and fracture will occur. Okay. So, the design of the wire die is such that bar being pulled experiences the compressive force, and which in turn causes the yielding or the plastic deformation of the metal, and that in turn leads to the reduction in diameter of the bar coupled with the increase in length to produce the wires. Okay, so therefore, the design of the die is crucial to avoid the breaking of the material due to the pull force being applied during the wire drawing. And but at the same time, since the wire or the bar will be passing through different sets of the dies, okay, then each time whenever material passes through one set of the die, it experiences the work hardening, and when the work hardening happens multiple times, okay, then its hardness increases, ductility reduces. Say material has passed through the 3 sets of the die, so it will be experiencing the work hardening 3 times, means there will be continuous increase in yield strength, increase in hardness, and continuous reduction in percentage elongation. So, material will tend to behave like a brittle material after a certain limit, and it may not show the enough tendency to get deformed during the wire drawing process, and in that case it may show the cracking tendency, okay, because material loses its ability to get deformed further. So, significant plastic deformation of the metal, especially under the low temperature conditions, causes the strain hardening, and when material continuous strain hardening being experienced by the metal at different stages of the wire drawing, when passing through the series of the wire drawing dies, it loses its ductility and experiences increased hardness and yield strength. Therefore, it becomes important to soften the material, and for that purpose in process annealing is carried out. Say after passing the set of the 3 wire drawing dies, it is subjected to the in process annealing. In process annealing is simple, that will be causing the recovery, recrystallization, inducing the softness, increasing the ductility, and making it suitable for further wire drawing without cracking tendency. So, basically when the material loses its ductility and significant increase in yield strength takes place, then to make it further suitable for the wire drawing, in process annealing is carried out, which through the recovery and recrystallization will be restoring the ductility, and which will allow further wire drawing in the subsequent stages without cracking of the material. So, as I have said, since the huge friction between the die and the wire surface takes place, so this is important to reduce the friction, and for that suitable lubricant is used. So, suitable lubricant is used during the wire drawing to reduce this wire die interfacial friction and reduce the wear of the wire drawing die, as well as for reducing the wire drawing force, okay, and the related power. So, these are also reduced. Since there is a continuous rubbing of the metal which is being drawn with the die surface, so the die must be made of very high hardness and which is also stable in terms of the variation in hardness due to any heating which is taking place. So, material not just be hard, but that hardness must be stable. So, we try to use the material such that it is of the good thermal stability and good wear resistance, and therefore, we try to select as per the material which is being drawn, the kind of wear conditions being imposed, and the kind of wear that will be experienced by the die during the wire drawing process. We can use for softer metals, we can use tool steel, otherwise for harder metals we can use tungsten carbide and the diamond, depending on the material of the wire which is to be used for wire drawing using a particular die. Okay, the maximum reduction which is possible in wire drawing in one pass is about 40 to 50%. So, that is the maximum reduction that can be realized in one pass of the wire drawing through a set of the through one set of the die, and then subsequently the bar can be passed through the number of the die sets, say 50% reduction here, then 50% reduction further here. So, likewise we can continue to reduce the diameter of wire until the desired final diameter is realized. So, this you can say the multi pass wire drawing die set is used, okay, for wire drawing, and we can, in case of the multi pass wire drawing arrangement, we need to see that the material retains the enough ductility and if it loses its ductility, then we may have to incorporate the in process annealing during this wire drying process. Okay, how does the wire drying effect of wire drying on the wire which is being produced? So, the first things, because of the wire drying is a cold working process, so material is experiencing the work hardening, and therefore the wire which is produced by wire drying under the cold working conditions, it increases the tensile strength, hardness due to the work hardening, but at the cost of the ductility. Ductility is reduced because of the wire drying. So, greater is the reduction that is realized through the wire drying, greater will be the drop in yield strength and greater will be the increase in strength. Greater will be the drop in the ductility and greater will be the increase in yield strength. Okay. Since the cold working process is known to produce the good surface finish and good dimensional accuracy as compared to the hot processes, therefore, surface finish which is produced by the wire drying is really good and it produces the smooth and uniform surface. And similarly, being the cold working process, the wire drying allows close control over the wire dimensions, and which in turn helps in producing the high quality wires with very close tolerance. Okay. So, these are like say the first two are related with the variation in mechanical properties, and the other two are about the dimensional aspect where surface finish, that is the RA, and how close control over the dimensions is realized through the wire drying. And the core in effect of all these effects due to the wire drying is the cold working. Okay. If you go for hot one, then probably increase in strength and drop in yield strength will be limited, surface finish will be poor, and the dimensional accuracy will also be less because of that variation in thermal expansion and contraction, increased oxidation tendency, and reduced work hardening effect at a higher temperature above the recrystallization temperature. Okay. What are the important factors that will be affecting the wire drying process? So, there is we have three category. One is the die design itself. Okay. Then the material of the wire which is being material of the stock or which is to be used for processing or producing the wires. And third is the conditions which are being used for wire drying. Conditions of wire drying, like how, what is the speed of wire drying, what kind of lubricant is being used, like that. Okay. So, the process parameters related to the wire drying includes the die geometry is one, wire of the material is another, and the conditions which are related with the wire drying, like drying speed, friction, lubrication, etc. Okay. So, here the first parameter, that is the wire drying die design. Okay. You can see there is one angle alpha, this is called the die angle. Okay, this is one, and then there is a small section that is about the bearing zone. Okay, this bearing zone determines the final size of the wire that will be produced and the bearing length. This is the flat uniform diameter section. So, the length of that section is bearing length. This determines the final dimension of the wire that will be produced. Okay, and the die angle, that is the another one. So, this is the entry section and this is the exit section. Okay. Since the material is subjected to the reduction in diameter and increase in length, therefore, there is always difference in the initial velocity of the material at the entry and the final velocity that will be coming out. So, V2 is usually greater than that of the V1 because of this reduction in cross section and increase in length. Okay. This is similar to that of the rolling also that we normally see. So, as far as the die angle is concerned, the angle of the die aperture affects the drying force and the quality of the wire drawn. We will see later on that how the wire drying force is affected by the die angle. The bearing length is about the length of the die where the wire makes the contact, which determines the wire drying force and can affect the surface finish. It is usually 20 to 30% of the wire size. Okay. Then the reduction ratio, it is about the amount of the reduction that is realized in one pass, and this affects the drying force and the final wire dimensions. Okay. So, obviously, it will be depending upon the final size with respect to the initial size. So, that will be determining the reduction ratio. Okay. Now, the material properties, higher the yield strength, greater will be the force that will be required for the wire drawing purpose. So, higher yield strength requires greater force to deform and to facilitate the wire drawing. Similarly, higher the modulus of elasticity leads to the stiffer wire and potentially requires more force for wire drawing purpose. Similarly, if the material is having the greater work hardening tendency, then it will increase the force required for the wire drawing, that is one, and it will reduce the ductility rapidly, that in turn will increase the cracking tendency, or that will also increase the in process annealing requirement. Okay. So, the different metals which will be showing the different work hardening tendency, those which show greater work hardening tendency, they will be showing the greater cracking tendency, especially due to the loss of ductility, increased hardness. They also need the greater force for the drying purpose, and to avoid the cracking tendency of the high work hardening materials, in processing annealing may be more if the significant reduction in diameter is needed. Now, at what speed the wire drying process is being carried out. So, higher the wire drying speed can lead to the increased drying force requirement, because material tends to behave more like the brittle material. How higher strength and lower ductility when the material is subjected to deformation at a higher rate due to the higher drying speed, and it also increases the temperature during the wire drying and potentially affecting the wire quality that will be produced. Okay. Then the friction between the wire and die affects the drying force and causes the surface defects, and therefore, to reduce the friction we use lubrication. So, proper lubrication reduces the friction, that in turn helps in reducing the ensuring the smooth wire drying process as well as the good surface finish of the wire that will be produced. The temperature at which the wire drying, usually it is cold working process, no external heating is done, but due to the friction, due to the especially under the high temperature, high drying speed conditions, the temperature will go up. So, the temperature affects the drying force and the metal flow stress. We know that with the increase in temperature, say here we have temperature, here we have yield strength or the flow stress, then those flow stress will be decreasing. For different metals this drop is different, say for mild steel it will go like this, for stainless steel it will go. So, the drop with the increase in temperature is different for different metals. So, the higher the temperature, lower will be the flow stresses, and accordingly the force for the wire drying will be affected. As far as the application is concerned, since the process is primarily used for making the wires for variety of applications, say the copper wires are used in the electrical sectors for making the electrical wires and cables, and structural components are also produced using the wires. So, the drawn wires are used in applications requiring high strength and the durability, such as springs, cables and fasteners, and other industries also use the wires like automotive, aerospace and construction. This is the typical approach which has been shown schematically. So, this is the large diameter, the coil of the stock material, it is passed through the set of the die with the lubricant, and then when it is passed there will be the reduction in diameter of the wire, and then this is again rolled out in form of the coils. Okay, now as far as the mechanics of the wire drawing is concerned, we will try to see what are the various stress, strain, force and power related aspects of the wire drawing. So, as I have said, wire drawing is basically similar to the extrusion process in terms of the approach for reducing the cross section of the metal by passing the large diameter metal through the die. Okay. So, in case of the extrusion, what we have seen, say this is the die chamber and here we have large diameter material, this is posed. When it is posed, the material starts flowing through the nozzle. So, there is a great reduction in diameter, but here we apply compressive force. Reduction in cross section is there in both the cases, in wire drawing as well as in extrusion. But in wire drawing, what we do, the large diameter wire is passed through the die with the which will be leading to the or causing the reduction in diameter, but with the application of the tensile force. Okay. Tensile force indirectly causes the compressive force with the help of die, that is another aspect, but we have to apply the tensile force for causing the wire drawing. Okay. So, wire drawing is similar to the extrusion in terms of the approach involving the reduction in cross section of the metal by passing through the large diameter metal through the die. However, the two processes differ in respect of the actual stresses leading to the change in cross section. Tensile load is applied on the bar to cause the plastic flow of the metal for wire drawing, which indirectly applies the compressive load with the help of the die when the material is passed through the die, while extrusion process exclusively uses the compressive load. This is the first aspect. Then the second is about the dimensional change in stress strain, like that. So, the reduction in cross sectional area in the wire drawing is expressed by R WD is for wire drawing. So, RWD is for the reduction in cross section area in wire drawing, that is expressed by A1 initial diameter of the initial cross sectional area of the wire and final minus final cross sectional area of the wire divided by. So, this is for the stock material which is being used and this is for the wire which is being produced. So, A1 is the initial cross sectional area of the bar and A2 is the cross sectional area wire of the metal which is produced after wire drawing. So, obviously A2 will be smaller than the A1. In case of the large diameter stock metals, it is called the bar or rod drawing, and in that case, like say, the difference in the size between the diameter of metal before and after the drawing process is called draft. Okay. So, the draft is like difference of D1, that is the initial diameter of the bar, and D2 is the final diameter of the bar after the drawing process. Okay. Initial and the final diameter of the bar after the drawing. So, we use the draft in that case. True strain for wire drawing is obtained using the simple equation log of A1 divided by A2, assuming that the friction is negligible and there is no redundant work. So, that is how the true strain is observed, and this is rewritten differently, little bit differently, log of 1 by 1 minus W. Okay. So, this is how it is written in with the rearrangement of the RWD. We know that A1 by A1 minus A2 divided by A1, that is how it was written. So, this is the rewritten, it is like this only. So, RWD is the reduction due to the wire drawing. For the stress required to cause the plastic deformation under such conditions, ideal conditions of the deformation under the wire drawing, true stress is obtained from the average stress and the epsilon showing the strain. Okay. So, the average stress is obtained from that old or earlier equation where this is the true strain epsilon and the n is the work hardening exponent and this is the material strength coefficient for determining, this is the equation to be used for determining the average flow stress. So, average flow stress multiplied by the true strain will be giving us the true stress rate. Okay. There are multiple the empirical equations which have been developed for determining the stress required for wire drawing. This is one typical one where stress required for wire drawing can be obtained using this typical equation, sigma AB, that is the average stress 1 plus mu by divided by tan alpha is the that half die angle and phi is the one of the factor that is accounting the deformation aspects considering the redundant work, and the A1 A2 is the initial and the final diameter. So, here we see the sigma WD is the wire drawing stress, mu is the friction and alpha is the die angle, that is the half angle, and the phi factor phi accounts for the inhomogeneous deformation considering the geometry aspect affecting the redundant work, and that this phi is obtained using this equation of like 0.88 plus 0.12 multiplied by DAV, that is the average diameter of D1 plus D2 divided by 2, and L is the length metal and the die contact length, that is obtained from this equation D1 minus D2 divided by twice of sine alpha divided by twice of sine alpha. Okay. So, once we have the phi value, then the drawing force can be obtained using the cross sectional area of the wire drawing die and stress required for wire. So, the drawing force is obtained using the wire cross sectional area of the wire that is being obtained from the die, that is A2 basically, and the sigma WD, that is the stress required for wire drawing, and that is why A2 multiplied by sigma WD stress required for wire drawing. So, force for wire drawing F, that is obtained from the A2 multiplied by sigma WD. A2 is the same, and WD A2 can be obtained from the pi by 4 square D2 square. D2 is the diameter of the wire that is being obtained after the wire drying. Say initial and final, what is happening in one pass. So, that is how it is used. And then sigma AV, that is the our average stress, and this is the same component what we have seen here. Okay. So, 1 plus mu divided by 10 alpha into phi into log of A1 by A2. Okay. So, this is how we can determine the force. Now, if we know the force and we know the drying speed, then these two can be used for determining the power required for wire drying. So, force for wire drying and the speed of the wire drying, these two are used for determining the power required for wire drying. Practically in one pass, single pass, wire drying allows the maximum reduction of 0.5, but practically it is the 0.3 value which is used for the wire drying in multiple stages. Now, we will try to see what are the common defects that are encountered during the wire drying. So, one is the center cracking. This occurs due to the tensile stresses, especially when the material is experiencing the tensile strain in the center of the wire, and this kind of the cracking is triggered in the presence of the brittle phases or inclusions in the material. Chevron cracking is these cracks form at the wire surface, particularly at the low die angle and low reduction ratios when they are realized through the wire drying. Seams are basically the longitudinal scratches in the material, often caused by the improper lubrication, improper die condition, and inappropriate selection of the process parameters. Now, scratches and the die marks on the wire which is being produced, this occurs primarily. So, this is basically the surface imperfections which are produced on the wire surface due to the poor die conditions, improper lubrication, or inadequate or improper set of the process parameters. Check marks are basically deep transverse cracks on the wire surface, then that can develop during the repeated wire drying. So, this is attributed to the reduction in percentage elongation and increased hardness. When the material loses its ability to get further elongated, so it starts cracking. So, die wear is basically when the die wears out, there will increase in diameter of the wire, increase in diameter of the die opening, especially of the bearing area, and that will be leading to the inaccurate dimensions of the wire that will be produced, and the surface imperfections due to the, especially this happens when the wear is unequal. If say increase in diameter is same, if the die surface wears out equally in all the zones, then it is fine, only the diameter will increase. But if the wear is unequal, then even shape of the wire that will be produced will get improper, that will be incorrect, and therefore, the surface imperfections will be produced on the surface of wires which are being produced. Now, I will summarize this presentation. In this presentation, basically I have talked about the approach of the wire drawing as compared to that of the extrusion. Then what are the various stress, strain and power related aspects of the wire drawing? What are the important process parameters? How the material is affected by the wire drawing process? And how the wire drawing affects the properties of the material which is produced in the form of the wires, and then what are the common defects which are encountered during the wire drawing. Thank you for your attention.